so that you can, you know what your answers were. So first, 31 degrees and about 21 newtons, depending on which quiz you had. So let's start with the inclined plane one. Is that one fine for you guys?
Yes.
This one had a box on a ramp. So terribly exciting, all these boxes and ramps. And this class, it appears this one was easier than what other classes. More of you got this one right in this class than some of the other classes. Probably because there's one just like it in your homework, but maybe not. Not everybody does their homework. So we'll say theta, and this is 5 kilograms. So the coefficient of static friction is 0.6. That's the fancy word for friction is up to 60% of the normal force. So I'm going to start using the correct language pretty soon, but right now I'm not using the correct language. I'm using a metaphor that you are comfortable with, and you're comfortable with percentages. So I state that friction is equal to 0.6 N. That's what it means when I say this friction is up to 60% of the normal force. Truthfully, this should be an inequality, but we'll get to that in a day or two. So I'm going to start with a free body diagram, which means a dot and then a couple 3 arrows. First arrow, weight of the box, 50 newtons. Weight is mg. The weight is not 5, the weight is 50. The mass is 5. A few of you didn't do that. The next force has to be drawn perpendicular to the normal force. I still don't know what some of you are doing. That's perpendicular to the ramp, right? Perpendicular to the surface. So I don't know what's happening, why you can't do that. But it's like 3 of you in this class. It was like 8 in the last class and 7 in the other class before that. Normal force. Friction must be perpendicular to the normal force. It has to be aligned with the ramp and try to prevent motion. Those 3 things dictate that the frictional force has to be this way. And this should look like a right angle. Should look like one. I should start taking all the ones that don't even look close and put them on the bulletin board so that we can say, hey, this is what they think a right angle looks like. You have a protractor. Find 90 degrees on it. There it is. There's your right angle. Okay? Also, you have a ruler, right? Doesn't the ruler have little markings on it? And those markings are perpendicular to the ruler. You have many ways of trying to make sure you have a right angle. Make it closer. I'm going to zip through some of this because we've done it so often, but I will remind you that I still have people who don't know where theta goes. Line up the normal force first. That's where theta goes. Then line up the other one. I had somebody argue with me at the end of last class period because their negatives didn't line up with my negatives. I don't care. Does it matter what direction I make positive or negative here? It does not. So if I make this positive and this negative, then mine are going to go one way. If you did the reverse, then yours will be the reverse. The math will still work. This part is arbitrarily chosen. I have to take the one off-axis vector and break it up into components. That's a component, and that's a component. Now, I have this weird thing happening where people are saying, okay, I've gotten this far. You told me to write this, so I'm writing it down. I'm writing on both of them. And then they go to write their net force equation, and they put W minus mg cosine theta plus n equals 0. I don't know what the heck is going on here. So if that's you, and it could be, the moment you break your off-axis force into components, it's gone. Get rid of it. You don't need it anymore. These take the place of the vector that was there before. They are the components that explain how much of that vector was in the x direction and how much of that vector was in the y direction. So once you've done the trig, they take the place. That's what that's all about. That's what breaking it into components is about. They take the place, so now you have 2 one-dimensional problems. There's one of them, there's the other. Net force in the x direction equals 0. So that's going to be mg sine theta minus friction equals 0. Net force in the y direction equals 0. So normal minus mg cosine theta, God, that's messy, equals 0. I'm trying to write too fast. Take your time. There. We have applied Newton's law and the force concept model to this problem and developed two relationships that we might be able to use to solve this problem. That's the 8 points. If you can do those things. Now you have to do something with them. And whoa, I saw some weird stuff here. Now I haven't graded more than 3 or 4 in your class, and many of you got this part right. But as I said, all right, you gotta do some math here. This is where your 2 points come from, because that's about what it's going to be on the actual AP exam. And there's a number of ways you could do it. I think most of you would go the route of substitution, because you have friction equals 0.6 times the normal force. So you can do substitution. You want the angle. So you need to get one equation that has both things with the angle in it. There are other ways I could show you how to do this, but I think this is what most of you do. So that suggests that friction equals 0.6 times mg cosine theta. Right? Substitution, I just took this and substituted it there. Everybody clear with that? Do I need to explain it? All right. That also means that this can be subbed over here. And when I do that, I get mg sine theta equals 0.6 mg cosine theta. Mg is a non-zero value. I can cancel it out. So the mass actually was extra information. You didn't need it. I can divide both sides by cosine theta. And when I do, I get sine theta divided by cosine theta equals 0.6. So tangent theta equals 0.6. So theta equals 31 degrees. Some of you did all sorts of weirdo math for this. Unnecessary. Unnecessary. There's some weird stuff going on. And you got some stuff. However, I've seen some weirder stuff today. So we're gonna talk about at least one of them. You have a question? Okay. So that's it. That's this problem. 8 points to get all the way to here. 1 point if you made any reasonable attempt at substitution, and 1 point for doing it correctly and getting the right answer. I think that's very fair distribution of points at this point in the year. So, the wall question. The wall question had what amounts to a wall and a box being pushed up the wall. And we had seen this problem before, so I don't feel so bad about it, except for all the number of people who don't know where 65 goes. We'll get to you guys in a minute, but we want to draw a free body diagram to deal with this problem. That free body diagram will start with a dot and the indication that the first force is weight, 20 newtons. And then I have this applied force that I have to use. I'll try and make them look about the same. That looks good. I don't know what the value is, but I know the angle is 65. Wow, there's a lot of you put 65 here. Wow, a lot of you. Boy, a lot of you. I am frustrated with that, considering that so many of you got A's in geometry. Do you see the line I've drawn and why I've drawn it? I hope so, because this angle is 65, so this angle has to be 65. That means this one is 65 over here. I really wish it was like a thing where I was allowed to go and say anything that you were taught originally that you can't do now, that you got an A for, we should be able to go back and take it back. I know you would really not like that policy, but I find it to be a clear and righteous policy, right? You like having that A in your transcript. I just want to use it. And I can't forgive you for that one. I've seen it. I have to help this kid in my research class who was in geometry all the time. And she at least knows those rules, but geometry was mean, right? Because it mixed in algebra with all of that and said that, you had two angles that were the same, but they put like x plus 5 as one of them and 3x minus 2 as the other, and you had to figure out which ones were equal. And remember all that garbage in geometry? Yeah, but you all got A's. So, not all of you, a few of you didn't, but many of you did. Stop whispering. I'm listening. I can hear you. Normal force, right? Has to be perpendicular to the wall. The wall is this way. Perpendicular means that way. Now, here's the thing that a lot of you did wrong on this one. Friction's up. I know you drew it downwards, a bunch of you. Why? Because that's the way it was when we did this exact same one in class, and so you just copied your old work? I mean, I could think of other reasons, but the problem said, what is the minimum force required to hold a book against the wall? If I apply less force, is the book going to suddenly go up the wall? I don't think so. I think it's going to go down the wall. So friction is acting upwards to try and prevent it from sliding down the wall. If I asked, what is the maximum force I can apply before the book slides up the wall, then friction would be downwards. Friction's a little tricky. You got to think about it. I'm trying to help you think about it. Now that's just one point, right? Only one. I'm sure everything else is perfect unless the angle's on the other side. Now we're up to 2 points wrong. They start to add up quick, don't they? When there are only 10 of them. So I'm going to put a coordinate system in that looks something like this. And all that talk was to allow all the people who I said should be trying out the other problem to try and do it. And I see that some of you are, and then some of you aren't. And you're going to beg me to let you do your homework late and stuff. And I'll be all sad when I have to say no. All right, we good? See all the things I've done? We good with that? I'm going to put I have to take that force and break it up into components. So there's one this way and one this way. I'm not drawing the triangle. I'm just drawing the components because I know that this one represents the opposite side. It'd be up here, just drawing it on the axis. So that one's going to be F sine 65. And then this one is going to be F cosine 65. I'm doing that just so that I could go ahead and I don't know, just take that away and that away. So now all I have in here are the components of all the forces. Looks good? All right, so this is where we do the net force part of this. So net force in the x direction equals 0. So that's going to be F sine 65 minus the normal force equals 0. A lot of you did like N2 and N1s. Isn't F easier than N1 and N2? You don't have to do it. I mean, some normal forces are obvious, but if you can escape the wretched subscript with another subscript for the x direction, another subscript for which one it is, you may wish to try. Net force in the y direction also equals 0. That'll be F cosine 65 plus friction minus 20 equals 0. It is right here where all of you who put the force in the other direction say, well, it's just a minus sign. That's the only thing that's wrong is I just had one wrong minus sign. No, you had full conception of the problem incorrect. That's the way the physics teacher says it. You fully conceived of it wrong, so you deserve 100% nothing. But that'll probably only be worth 1 point. All right, we're largely done. That's 8 out of 10 points. We have applied the force concept model to generate two relationships that might be able to be used to answer the question. The question was, what is the size of F, the force? Could we do the problem? Yeah, we sure could, because we know that friction equals 60% of the normal force. I think there's some substitution that can be done in here. Do you agree? So let's give it a try. That's not 0.6 N, that's 0.6 of the normal force. So the normal force can be found here. So I think we do that, saying friction equals 0.6 times F sine 65 degrees. That's the first substitution. Now I have another substitution. Correct? Good. So I will get f cosine 65 plus 0.6 times f sine 65 equals 20. This is one equation and one unknown. Factor the f out. And I'm just doing the math to be nice. I would kind of say I was done a minute ago, but I know some people really need to see more of this. And part of the reason is that, can I show you guys what I saw in some papers today? You see that we're done now, right? That this is all just some number. I put in cosine of 65 and 0.6 times sine of 65 and add those together, get like 0.9 something, and then 20 divided by 0.9 something gives you 21. That's where that comes from. I've seen something weird today. I've seen people looking at this and trying to decide what to do, like not even sure what they're supposed to be solving for. And then decide to divide both sides by cosine 65, probably because they heard me say, whenever you can divide, and get sine divided by cosine, that's tangent. And they've done that, and here's where it gets a little freaky. Oh, you can't do a lot of what's happened here. First, the f disappears as if it never existed. That's fun. I like that. Let's say they didn't do that, but many people did. Like just hand wave. Now this is what f equals. But let's say they didn't, and they had the f here still. You can't do this. I mean, you could, but then this better be 20 divided by cosine 65. You have to divide both things by this. But I bet I can point to a paper in this class where this was done. Bye-bye.